Hello guys, welcome to Sigma Tech. We have a Lenovo board today, that is NM8272, which you already seen on the earlier video. I made a video about how to connect 19 volts if you do not have a DC jack. It is the same board and the video is continuation of it. The problem is this board is not turning on and the win section is having a P channel circuit. So let's continue this. If you have not watched that video, please click the I button and you can watch it, the first video. So let's get started and try to fix it, this board. So let's do a cold checking first. We'll start from major components, from the coils. So this coil doesn't give a beep, it's a battery coil. Then here we are getting 1.3 resistance, no beep. This must be related to this one. Here also no beep. Here we are getting 1.4. On the second coil there is no beep. This is 3.35 volts coils. So let's check it out further. Okay, here there is a shorting. We are getting 1 point. Let me check it on the diode mode. Yes, there is a shorting here. Here also there is a shorting, it seems. On the resistor, CLR resistor, it's okay. So let's see. So let's connect the 19 volt and check it out whether if any component is heating or not. So we have soldered it with the 19 volts lane. Now let's give the voltage. Okay, so the 19 volts main rail doesn't seems to be shorting directly, but there is a short. As you can see here, there is no rise in ampere. So now what? We have to check it out one by one from the 19 volts. Where is the problem? And then we can sort it out. Now let's check the voltages. So here at the DC jack, we are getting 1920 volts approximately. 20 volt we are getting here. Okay, and then after the DC jack, we have a fuse here. Here also we are getting 20 volts. Let me zoom it little bit. Hopefully you can see it now. So here is the fuse. Here we are getting 20 volts, and then we have a, this side also we are getting 20 volts, and then we have a coil, two coils here, small coils. We are getting 20 volts, and after the coil we have first MOSFET here, that is PQ301. At the drain of this MOSFET we are getting 20 volts. After the drain, the other side source, we are getting 20 volts. Okay, and if we check the gate of this, at the gate also we are getting 20 volts. I think gate is this side. At the gate of this MOSFET we are getting 20 volts. That is wrong. We are supposed to get low voltage here, and the source of this MOSFET is connected to the other MOSFET source. Here you can see source also we are getting 20 volts, and at the gate of this MOSFET 20 volts. At the gate of this MOSFET and this MOSFET we are supposed to get low volt. Now let's check what we are getting at the drain of the second MOSFET. There is no voltage. Okay, this is the problem. this 19 volts 20 volts should pass from these two MOSFET and will come to this CLR, the main resistor. Here we do not see any voltages. Okay, so there is a problem with this win section because we are getting higher voltage at the gate of this MOSFET. So this is what this video is about. I have already marked on the schematic to make it easy for understanding. Let's switch to the schematic and try to understand what is the problem and what causing it, that not letting the 20 volt pass from this secondary MOSFET. So guys, here is the schematic, and here I have already highlighted it. What are the components which we need to understand? This is the win section of this board. Okay, the board is G4070. Okay, it's a G5070 actually, and part number is NM_A272. So here is the first MOSFET which I showed you, and here is the second MOSFET. What's happening is this 19 volt is coming to the drain of this MOSFET and it is passing. It's passing because there is a diode which is towards the source. So easily it is passing to this side, and this same 19 volt is passing to this side from here to here. Okay, and then what's happening is the same 19 volt is going till here, the 20 volts, and it is going towards this side to the gate of this MOSFET, and also it is going from here to this gate of this MOSFET. Why? Because this circuit is not working. Why it is not working, that we need to understand it. So here they have given two transistors, one is PNP and the other one is NPN. I'll show you a image of it, how we can understand easily which is NPN and which is PNP, and the rest is N channel MOSFETs given here. Here this is N channel, here this is N channel, this is also N channel, and this is also N channel, and this is also N channel. So to function it properly, these two MOSFETs should be in off condition. How it will be off condition? If this voltage comes here, this MOSFET will start and this ground will pass here. Okay, if this ground passes here, then this is also N channel. If this ground comes here, this MOSFET will be in cutoff mode because this will not be available. So if this MOSFET will remain in cutoff mode, then this ground will not pass here, and then this PSCIN will come. Okay, it will come from this IC. This IC will be sending all these things. I'll explain you later. Okay, if this PSCIN comes here and it also goes to this MOSFET. So first if it comes here, this will be functional and this ground will shift to this place, and this resistor will form a divider. Okay, this resistor will form a divider, and then the right voltage will go to the gate. You have to calculate using voltage divider calculator. You will find out how much voltage will go to the gate of this MOSFETs. Then this same voltage, this 3.3 will come here, and this ground will go because it's a N channel. If the voltage comes here, the ground will shift here, and the voltage will stuck here. This 90 volt will not come here, and this is N channel. So if the voltage is not present, this will not be functional, then this ground will not shift here. Okay, if this ground is not shifting here, then this again will be in a cutoff mode. Okay, if these things are off, then this will functional, this will be functional, and it will form a divider. If these things will work, then this will not form a divider, and this 19 volt will not pass from this MOSFET. It will stuck till here. To get a lower volt here, this divider should function. How it is functioning? Let's find out. To function it properly, we need to find out this PSCIN, from where it is getting, from where it is coming. Let's find out. Okay, so here is the circuit for this PSCIN. Okay, this circuit is nearby the IC itself, and how this is getting formed, we need to understand. This here BQ24733, BQ24737, this voltage is coming from IC itself. Here REGN pin number 16, this voltage, the IC is generating this voltage. It's a 6 volt. This 6 volt is coming here, and then this ACPRN also is coming from the pin number 5. Okay, pin number 5 is coming here. Maybe it's a less voltage or a ground. I mean, there shouldn't be any voltage because this is N channel. If this is N channel, if we get a voltage here, then it will turn on and this ground will again go up. Okay, so maybe this is a negative voltage. Otherwise this 6 volt will come here and this will be functional again. So if this is a negative voltage, then this 6 volt will not go here and it will form a divider here, because ground is already there and here are two resistors. So here 6 volt will get two resistors and a ground, and it will form a divider. So this will divide this 6 volt, and this PSCIN 3.3 volt will come to 3.3 volts will come from here, and the same thing will go to this place here, and then things will start working. Okay, so this is how the PSCIN is working. What we need to find here is whether the IC is releasing this ACPRN or not, on what state it is releasing. Is it giving beep or is it giving voltage? It should be 0 volt. I mean, it should be negative voltage. Okay, and how this IC is functioning, we are getting here P2 19 volts, and also we are getting Win, that is 19 volt from here. Here is the 19 volt and here is the P2 point. These two are coming to the IC, and then IC is generating this ACPRN and REGN. Suppose we do not get this REGN, then this will be not functional. So let's find out what we are getting at the pin number 5 of this IC, and also pin number 16 of this IC, and how much we are getting at this point PQ998B. This must be 6 leg IC, whether we are getting 3.3 or not at the page at the pin number 3 of this MOSFET. So let's switch to the microscope. So guys, let's measure the voltage. Here is the BQIC, that is PQ301. If I tilt the board little bit, you can see it's a BQ737. Okay, now as per the schematic, here we have to have all these voltages, that is pin number 20, pin number 6 and 5 and pin number 16. Let's find out whether we are getting the voltages or not. We'll check it out. Pin number 20 first. So pin number 20, 5, 10, 15, 20. Here is the pin number 20 and we are getting 20 volts. Here you can see 20 volts we are getting. 20 volts we are getting. Then pin number 5. Pin number 5 is this one. Pin number 5 we are not getting any voltage. A pin number is AC, okay. This might be negative, okay. Otherwise our AC pack-in PSCIN will not function. So here you can see there is no voltage. Pin number 5. Then pin number 6, AC detect. Pin number 6, how much we are getting? 2.6. 2.6 here we are getting, you can see 2.6 we are getting. Then we have pin number 16, REGN, 6 volt we are supposed to get. 5, 10, 15, 16 here. 5, 10, 15, 16 here. We are getting 6 volt. You can see here 6 volt is coming. That means the IC is functional properly. That means the IC is functioning properly. There is a problem somewhere else in the win area itself. Okay. So let's try to find it out on the win area itself, and then we will see what is the next. Okay guys, so let's check the win section once again. I'll use this multimeter as I am comfortable in this one for cold checking. Hope you can see it. Yes, you can see it. One of the wire is faulty again, so I have to change it, but for now I can manage this one. So let's check it out. Here we got the voltages earlier, so there is no short. Okay, on the first MOSFET nothing. Yes, you can see guys, the first MOSFET itself is beeping. No other component is beeping. Second MOSFET is giving proper value. So drain to source, the first MOSFET is beeping, and get to source also is beeping. So this MOSFET is completely short, but on the CLR register there is a value. Okay, so this MOSFET itself is faulty. Let's replace this, and after that we will check it out whether we are getting the 19 volts at the CLR. Then we will try to sort it out the second part, that is the 3.35 volts, but I'll not cover this on this video. I'll make another video. This time I have to explain you how this P channel win section works. Okay guys, so the MOSFET has been replaced. Now let's check it out whether it is okay or not. Okay, so it is working condition. Now let's inject the voltage once again and check how much we are getting, or if the 3.3 volt lane is heating up. Okay, so we have connected the ground and main line. Now if I can show you, here you can see it is taking 21 and this IC is heating. So let's disconnect it, because the IC is getting hot very fast. That means this section is start working. Let's find out what are the voltages we are getting, and then we will wind up. But to check it, we need to disconnect 19 volt from this side. So let's disconnect it and then we will check that one. So guys, here we have disconnected 3.3 line, and now we will attach the ground. Now you can see the ampere is not rising, and we can easily work on this win section. So let's find out whatever was not coming, it is coming now or not. So here is the CLR. So here is the CLR. First we will check it out directly, CLR how much we are getting. We are getting exactly. Okay, now gate of this MOSFET. The gate of this MOSFET is this side. You can see we are getting only 5 volts, and gate of this MOSFET. So here also we are getting 5.3, approximately 5 volt. That is why this circuit is functional. Okay, if you can check here, 20 volt 16, here also 20 volt 16. Now this circuit has become functional. So as I told you, the IC is releasing what? ACPRN and PSCIN is coming from a circuit. The circuit is here. This is the circuit. Now let's check it out. Now let me show you whether we are getting it what we were supposed to get. So we are supposed to get PSCIN from PQ994B, PQ998B, which is here at the gate of at the pin number 3. At the pin number 3. Now let's measure it. Let me see once again. Let me see once. Okay. So the pin number 1 of this is this side. 1, 2, 3, 4, 5, 6. So pin number 3 is this side. Let me turn it. Okay guys. Now pin number 3 of this MOSFET. You can see we are getting 3.3. This is the PACIN. If this PACIN does not form, then this circuit will not function. So guys, if you have learned something from this video, please subscribe my channel, because subscribers are the most important thing on the channel. Do not forget to subscribe, and if you learn something from this video, please give a like to the video as well. Thanks for watching. Have a nice day.